Hello, you're welcome to MasterTMathsclass. And in this live class, I want to look at the topic in mathematics, which is indices. So we want to look at indices in this class. Then we will solve some interesting questions on indices. And before then, let's look at some laws of indices. So we have laws of indices. And here, these are the laws that we are going to be using when solving problems related to indices. The first one here, we have, when we have same base multiplying, like we have a raised to power n times a raised to power n. Here we can summarize this as a raised to power m plus n. This same base multiplying, we can add the power. That's the first law. Then also we have the second law. When we have same base and they are dividing, that is a raised to power n divided by a raised to power n. Here, this becomes a raised to power m minus n. Then, next, we have anytime we raise a number to power 0. For instance, we have a raised to power 0, this is equals to 1. Now, we can also give example. Here, we can say e.g., when we have 2 raised to power 6 times 2 raised to power 7. Of course, this will be 2 raised to power 6 plus 7, which is equals to 2 raised to power 10. And similarly here, when we have 2 raised to power 10 divided by 2 raised to power 5, this will give us 2 raised to power 10 minus 5. This is equals to 2 raised to power 5, and so on and so forth. And here, e.g., whenever we have any number raised to power 0, for instance, 5 raised to power 0, same thing as 1. Then we also have some other laws. Let's take this as number 4. When we have a raised to power n, then all raised to power n. This is telling us that this power multiplies and becomes a raised to power mn. For instance, if we have 2 raised to power 5, then raised to power 4. So this one, it's telling us that we have 2 raised to power 4 times 5, which becomes 20. 2 raised to power 20. Then also we have, whenever we have a raised to power minus n, this is called fractional index. Or, sorry, this we can call it negative index. Negative. So this will turn to 1 over a raised to power n. 1 over a raised to power n. Okay? Then also we have something called fractional index. So this one we have a raised to power 1 over n. Yeah, this is same thing as nth roots of a. Okay, let me give an example here. You can say e.g., when we have 2 raised to power minus 3, this is same thing as 1 over 2 raised to power 3. The negative here has become the inverse, which serving as 1 over 2 raised to power 3. Okay. Now, here we have fractional index. That is a raised to power 1 over n is nth root of a. E.g., when we have 9 raised to power 1 over 2. 9 raised to power 1 over 2. It becomes square root of 9. This 2 here serving as the n here we have is now 2. And when we have 2 here, the same thing as square root. And this is 3. And let's have another example. If you have 27 raised to power 1 over 3, this is like we have cube root now of 27. A number that can multiply 3 times will give us 27, that's 3. Okay? And so on and so forth. And to generalize this particular number 6, we have also, when we have it like a raised to power m over n, this becomes nth root of a then raised to power n. So in this case as well, is as we having it as raised to power 1. But anything raised to power 1 is still that same thing. So that's why we have it like this. So generally, a raised to power m over n is nth root of a raised to power m. So for instance, if we have 9 raised to power 3 over 2, this will give us square root of 9 raised to power 3. And root 9, that's 2. I mean, that's 3 rather. That's 3 raised to power 3. And that's 27. So that is for that. Okay? So when we master the laws of the indices, we'll be able to handle questions on them. Now let's look at some simple question here on indices. Okay, thank you for staying tuned. I want to solve some simple question here on indices. Now let's look at the first one. Simplify. Simplify 27 raised to power 2 over 3. Now, solution to this, from here, we can apply the law. You know, one of the law, that's number 6 or so, that we wrote earlier, that we considered earlier. And from what we have here, which is 27 raised to power 2 over 3, we can apply this law that when we have a raised to power m over n, it's same thing as n root of a raised to power m. Okay, so here, this will become cube roots of 27 then square. So that is it. That's what we have. Of course, we can use this if you like to raise it to power 2. And same thing here. It's still same thing. Now, finding cube root of 27, it means number that we multiply 3 times. That will be 27. That's 3. So this is 3 square. And similarly, simply this is 3 times 3, which is 9. So it means what we have here is now 9. So that is how this is solved, applying that law of indices. Now, okay. Now let's look at another one here, which is also on the law of indices. We have number 2 simplify 4 raised to power minus 2 multiplied by 2 raised to power 3 divided by 8. Now, when we look at this clearly here, this is negative index. Let's leave it first. And we have 4 raised to power minus 2 times. Okay? Actually, the first thing we should do, we should try to make sure we are dealing with the same base, if possible. Okay? Because, in indices, we have the first two laws is saying when the base are the same thing. So we can actually make this to have same base. And we can write 4 as 2 square, which is raised to power minus 2. Then times here we have 2 raised to power 3, which is divided by 8. Also, we can write that as 2 raised to power 3. Okay? Now, and when you look at this, our work is easier here. Why? Because this is multiplication and this is division. This same thing here. Just like when we have A times B over B, we can say that B cancel B and we have A left. So we can say 2 raised to power 3 cancel 2 raised to power 3. Okay? And we just have 2 raised to power 2, then all raised to power minus 2 left. And don't forget that there's a law that says A raised to power m raised to power n, same thing as A raised to power mn. Now, this power here multiplies, and minus 2 times 2 is minus 4. So we have 2 raised to power minus 4. Then also, the negative power here, negative index from A raised to power minus m is the same thing as 1 over A raised to power n. So easily here, we can say this is 1 over 2 raised to power 4. Okay, and 2 raised to power 4 actually is 2 multiplying itself 4 times, which gives us 1 over 2 multiply itself 4 times, that's 16. So that is that. So that's 1 over 16. Okay, so that is for the third question. Second question here now. Also, let's look at another one briefly. Still on indices. Okay, so the number 3 questions we have here is that we should solve the equation 3 raised to power 2x minus 1 equals to 27. Now, let's solve this. The first thing we should do whenever we have equation involving indices, let's try and make the two sides, both the left hand side and the right hand side, to have same base. Same base. This is base 3. Can we make 27 in base 3? Yes. Why? Because 27 is 3 times 3 times 3, which is 3 raised to power 3. 3 multiplies itself 3 times, 3 raised to power 3. This equation now becomes 3 raised to power 2x minus 1 equals to 3 raised to power 3. Then there is a law that backs this up, also in the law of indices. That is when we have a raised to power n equals to a raised to power n. Same base, then the power will be equal. We have m now equals to n. That is, here now we equate this power since we have same base, so that this becomes 2x minus 1 equals to 3. Okay, solve this simple equation. Just take minus 1 here, become close. And we have 2x equals to 3 plus 1. That becomes 4. So divide both sides by 2 here to get x. It means x equals to 2. Okay? So these are some simple equation we have under indices. Okay, so let's look at the next one. Still under the application of indices. Okay, now number 4, simplify. Simplify 16 over 81 all raised to power 3 over 4. Okay, now let's simplify this. It's also interesting expression that we can apply indices for. Let's try and make what is in the bracket. Actually, applying the law of indices, fractional index, a raised to power m over n, same thing as nth root of a raised to power m. See, this is what we need here. So that means the expression here is just like we have 4th root of 16 over 81 all raised to power 3. Okay, so when you interpret it that way, we have it. And 4th root of 16 is 2. 2 multiply itself 4 times, give us 16. And 4th root of 81 is 3. 3 multiply itself 4 times, give us 81. Then all raised to power 3. Then there is a law of indices here that's applicable to this. That's when we have a raised to power a over b all raised to power n. We can write this as a raised to power n over b raised to power n. That is, here, this becomes 2 raised to power 3 over 3 raised to power 3. And this becomes 2 raised to power 3 to multiply itself 3 times. That's 8 over here. We have 27. So this is simplified form of this particular expression. Okay? I believe you are enjoying this class. So don't forget to give a thumbs up and also subscribe to this channel. Now let's look at another one. Okay, and let's call this number 5 here in this class. So solve for x, the 5th question. Solve for x in 5 raised to power x equals to 1 over 125. Okay, now we try to make the left hand side also and the right hand side to have same base. Okay, we can write 125 in base 5. So this 125 same thing as 5 times 5 times 5, which is 5 raised to power 3. That is, this equation becomes 5 raised to power x equals to 1 over 5 raised to power 3. And here, we can reverse that law of indices. That when we have a raised to power minus n, this same thing as 1 over a raised to power n. So now, reverse it from here to this side. That is, here, we can express this. And we have 5 raised to power x equals to 5 raised to power minus 3. Now, also from a raised to power m equals to a raised to power n. Same base, now m equals to n. So directly here, we have same base. And therefore, x is equals to minus 3. That is, the solution to this is minus 3. So that is the application of those law of indices. I believe you have learned one or two things in this class. So don't forget to like and subscribe. And also part of this channel by joining our membership package. So we hope to see you in our next class and have a wonderful day. Bye for now.